weird green glow spotted in atmosphere of Mars. It's the first time the emission has been seen on a world beyond Earth. So let's jump into the video to see green glow spotted in atmosphere of Mars. We publish good content videos every day. If you're not subscribed to the channel since, don't forget to tap the subscribe button below, otherwise I will hypnotize you. The atmosphere of Mars has a distinct green glow just like Earth's. The European Space Agency's Trace Gas Orbiter (TGO) spotted an emerald glow in Mars' wispy atmosphere, marking the first time the phenomenon has been spotted on a world beyond Earth, a new study reports. One of the brightest emissions seen on Earth stems from night glow, more specifically from oxygen atoms emitting a particular wavelength of light that has never been seen around another planet. However, this emission has been predicted to exist at Mars for around 40 years, and thanks to TGO, we have found it, Gerard said, study lead author of the University de Liege in Belgium. The green emission is characteristic of oxygen. Skywatchers at high latitudes here on Earth can see this signature in the ethereal multicolored displays known as the auroras, which are generated by charged particles from the sun slamming into molecules high up in the atmosphere. But night glow is different. It's caused by the interaction of sunlight with atoms and molecules in the air, which generates a subtle but continuous light. This emission is hard to see, even here on Earth. Observers often need an edge-on perspective to make it out, which is why some of the best images of our planet's green night glow come courtesy of astronauts aboard the International Space Station. Day glow, the diurnal component of this constant emission, is even harder to spot, and it's driven by a slightly different mechanism. Night glow occurs as broken apart molecules recombine, whereas day glow arises when the sun's light directly excites atoms and molecules such as nitrogen and oxygen. European Space Agency officials wrote in the same statement. Gerard and his colleagues used TGO's nadir and occultation for Mars discovery instrument suite, which includes the ultraviolet and visible spectrometer, to study the red planet's air in a special observing mode from April through December of last year. Previous observations hadn't captured any kind of green glow at Mars, so we decided to reorient the ultraviolet and visible spectrometer nadir channel to point at the edge of Mars, similar to the perspective you see in images of Earth taken from the ISS. The team scanned the Martian atmosphere at altitudes between 12 miles and 250 miles. They found the green oxygen glow at all heights, thought it was strongest around 50 miles up, and varied with the red planet's distance from the sun. The researchers also performed modeling work to better understand what's driving the glow. Those calculations suggested the light is driven mainly by the breakup of carbon dioxide, which makes up 95% of Mars' thin atmosphere, into carbon monoxide and oxygen. TGO saw these stripped oxygen atoms glow in both visible and ultraviolet light, with the visible emission about 16.5 times more intense than the UV. The observations at Mars agree with previous theoretical models, but not with the actual glowing we have spotted around Earth, where the visible emission is far weaker. This suggests we have more to learn about how oxygen atoms behave, which is hugely important for our understanding of atomic and quantum physics. TGO has been circling Mars since October 2016. The orbiter is part of the two-phase European-Russian ExoMars program, which plans to launch a life-hunting rover called Rosalind Franklin toward the red planet in 2022. The Rosalind Franklin was originally supposed to lift off this summer, but technical issues with the spacecraft parachute and other systems caused the mission to miss that window. This type of remote sensing observation, coupled with in situ measurements at higher altitudes, helps us to predict how the Martian atmosphere will respond to seasonal changes and variations in solar activity. Predicting changes in atmospheric density is especially important for forthcoming missions, including the ExoMars 2020 mission that will send a rover and surface science platform to explore the surface of the red planet. So I think you guys enjoyed this video. Please make sure to click the like button below this video and subscribe to the channel.